We're ready? All right, cool. So thank you guys for coming today. My name's Chris Morgan. I work on the OpenShift team at Red Hat. I'm responsible for our technical integrations and things that we do with the entire partner ecosystem, ISVs, SIs, providers, the whole gamut of things. And Ankush, would you like to introduce yourself?
Yep. Hi, I am Ankush Chadha. I'm Senior Solution Developer at JFrog. I'm pretty much focused on partner integrations, kind of play with the products, explore new dimensions, stretch them. And before JFrog, I used to be a release and build manager at Oracle. I used to manage build release process of Fusion middleware product. Yep, that's it.
Yeah, and he's being modest. He's got the cool part of the presentation. There's some really slick demos that we want to get to. So we talked about it. We just said, hey, you know, do you think folks at 3:50 in the afternoon want to see 60 or 70 slides? Or do they want to maybe see a demo with just a few slides? And after a lot of back and forth, we decided on just a few slides. Did any of you attend the OpenShift session this morning? Okay, cool. So that actually helps as well. So we've kind of done things in two parts. We have two integrations between our products. One's with Artifactory and one is obviously with Xray, which is where we're going to focus this presentation on. But just kind of a quick overview, if you will, of what OpenShift actually is. Now, I could bore you with marketing slides, but I decided it's a tech conference, so we're going straight just to an architectural diagram, and I will explain what OpenShift is. So OpenShift is Red Hat's container application platform. And by container, we mean containers based on the now Moby spec, because the good folks at Docker Incorporated may charge me for actually saying Docker as we move forward. And it's also based on a project called Kubernetes. Are you guys familiar with Kubernetes at all? Hopefully that one, right? You know, maybe not OpenShift, but Kubernetes. So you can think of OpenShift as Red Hat's enterprise distribution of Kubernetes, right? So at Red Hat, that's kind of what we do. We take upstream projects and we make them ready for the enterprise, right? You know, we take Fedora and we make Red Hat Enterprise Linux. We take Wildfly and we make Java. Same thing with OpenShift, right? We take Kubernetes and we take the Moby project and we add a lot of usability and other features on top of it, and we deliver that as an enterprise SKU. Now, it's architecture. We won't go into all the details here, but some things that are going to be kind of prevalent here is we actually add the capability for developers to just take their source code and use it with their favorite runtime. You mentioned Java and Go, right? So you can just use the repository and get where you have everything, and that's insert that code into the container on its own. You don't have to worry about doing the Docker builds or any of those pieces. We handle it with a technology called source to image. And I think, are you still going to show that off a little bit?
Yes.
Okay, great.
Yep.
So Ankush is going to show it off. It runs on any kind of infrastructure. So that's anywhere Red Hat Enterprise Linux is supported is where OpenShift would be supported. So that's physical, virtual, private clouds, and public clouds. We're going to just kind of go into details and show you some things, but what we're going to really focus this presentation on again is the container itself and how do you secure them. Are any of you, this is a very participation focused kind of thing, are any of you using containers at all today for anything besides development? Is anyone trying to run them in production? That's surprising. All right, cool. So we have some folks running them in production. Does that scare you would be the next question, right, from a security standpoint. That's what we want to talk about. What are the things you have to consider when you get here? The other thing you missed this morning is Artifactory actually runs completely in an OpenShift environment as well and takes advantage of all the things that we provide and allow you to do in a containerized environment. And so when you combine those things, you kind of have the basis now between Artifactory and OpenShift to actually build your security story even tighter with what we have today. And we're going to see as we push forward what you're actually going to show us what we can do with Xray and OpenShift together to manage the security. Now, when you think about container security, we like to break it down into these 10 particular areas, right? Now, don't worry, this is not going to be too technically deep, but it will kind of go into some concepts that are there. The important thing to remember, with containers is they are really nothing more than a Linux process. And I'd like to think that a company that's kind of made its living based on a enterprise Linux distribution would know a thing or two about Linux processes, at least as we go through. But we're going to cover all of these areas in the presentation. But what's really important is when you look at OpenShift plus Artifactory plus Xray, and it's not showing the highlighted ones. They're not different colors.
No, it is. It is.
Oh, it is now. Okay. Sorry, colorblind. We're going to focus on those 4 areas. Will be where the demo is going to be focused, is where we're actually doing things jointly with our integration. But before we get to that, let's kind of go through each of these in just a slight bit of detail as we go forward. So again, the OS matters at the end of the day. Containers are a native Linux concept. They're nothing more than a Linux process, right? So you have to have an operating system if you're going to have a container. You know, even Microsoft, if you came to their session earlier, you know, they're doing some things around Windows containers and starting to kind of get their feet wet there, but even that validates the fact that the operating system is important. And you need to have something that's stable and secure and takes advantage of all the different kind of OS level features that are actually in place. Just another bit of curiosity, because I want to make sure folks stay awake. Because it was a lot of operations and admins, do you guys use Red Hat Enterprise Linux or any Linux today? And if it is Red Hat, do you use SE Linux? That's great. Do you like it? All right. You don't type set enforce 0 as your first step in a deployment. No, but the nice thing though, when you do this within an OS, you get to take all the advantage of SE Linux without it getting in your way. Because you want to make sure you use SE Linux to actually wall off that process. And if everything you're doing that's really important is inside of that process or that container, you're using SE Linux without having to worry about it. So if you're an administrator, that's awesome, right? It's just all the labels and everything are just there and they just work. When you're a developer, there's not something blocked by SE Linux to keep you from doing what you're trying to accomplish with your code. So it's really slick. Authentication and authorization. So when the Kubernetes project in particular first came out, you were cluster admin or you were not, right? And so you needed some kind of role-based access control and other pieces if you're actually going to lock down these containers, because you don't want everyone to have containers that are, have super privileged or root access capabilities. In fact, ideally, no containers have that except for a very small subset of them that you may need to actually manage the infrastructure. Things such as network segmentation and how do you ensure that container A can talk to container B or not talk, both affinity and anti-affinity. These are all the considerations that you have to kind of put into place when you look at where you want to have things from the authorization and role-based standpoint. Network isolation. So this is actually a really complex area as well, because there's a lot of networking at play in a container world, right? So let's say you've got an environment, it's running on VMs maybe. Each of those VMs have an IP address. Then on top of the VMs, you actually have the infrastructure of containers, and each container has an IP address. Now, you want to access any services that are deployed within that cluster. That's yet another IP address from a routing standpoint. So all of a sudden, the networking could end up being a pretty intense type of thing. And so ensuring it's secure, going back to what we talked about with the containers themselves being isolated, you want to make sure that maybe complete namespaces within the Linux environment can be isolated as well. Secure communications and other pieces are really important and a strong consideration you have to make when you look at this. The data security and persistence. So at first, when a lot of the container protocols and orchestrators came out, it was said, hey, everything's going to be stateless. So we don't have to worry about this, right? There's no persistence. And the fact of the matter is 12-factor, which is kind of what a lot of cloud native was called, was 12-factor. While interesting academically, most folks still have state in their applications, right? Everything isn't running with a Redis backend. You still have PostgreSQL, you still have MySQL, you still have something there to actually persist and store the state. And so being able to actually handle that persistence and do it securely all the way down to the storage layer, just like you do with the networking layer, is just as important in the container world. I mean, hopefully what you're even picking up so far is containers aren't this panacea that they've been made out to be in some other areas. The same problems you guys are dealing with now still exist with containers. They're just at a different level. And how you have to solve those problems is a little different as well. API management. So when you think about, okay, great, I've secured the infrastructure, that's where we've talked about so far, and I've deployed my services. Now I want people to access those services. Well, how do I handle that, right? How do I handle how things are coming in from outside the cluster? How do I ensure that these APIs are not called too many times, as could be the case, and all of a sudden bring down my entire service? Who can actually access these particular APIs that are running? All of these are considerations that you have to do as well. And then what about federation? So this is actually in development in the Kubernetes community, if you guys look at it. But this hybrid cloud thing that's been said a lot by a lot of companies, it's really interesting because, well, if I'm running a cluster, preferably it all needs to be in one place. If I start putting some nodes in a cluster in my data center, then some at Amazon, then some at Google, well, I've got data issues with replication. I've got to worry about overlay networks. You've got all of these latency issues and other things about creating affinity and anti-affinity policies. How do you do all that, right? How do I just share secrets to make sure that I can do something in that environment? So federation is something, it's on the roadmap because there's a lot of work, and if you guys are interested, you should actually check it out in the Kubernetes community. But that's really the next evolution of things when we look at it. But that's going to create more security problems as we go along, but it's something else that you have to consider. And then, finally from where I'm at, what's inside of the container, right? So for those of you that are using containers today, are you just pulling these containers down from Docker Hub and just using them randomly, right? That's probably going to be a little scary because you don't actually know what's inside of those things. And so ensuring that the containers are not only, commercially supported and those types of things, but that they're coming from a canonical source. I mean, that was a big driver for us, working with the Artifactory team. They're really strong in this space about ensuring that, hey, we know where this came from because there's an administrator that's responsible for putting everything that's in here. And so if we can point to this as where we're getting our source of containers and other artifacts, then, hey, we can at least take out one bit of an unknown when we get into this space. And so all of these together leads us finally to the fun stuff that I'm actually going to turn it over to Ankush. And what I want you guys to notice when we get in here, so I'm dating myself a little bit, but I grew up in the systems management area. And what was in systems management, you did capture, diagnose, and fix. That's what all the products did. They could go into one or all of those silos. And what's really fascinating to me is when you look at what we have with OpenShift and with Artifactory and Xray is you do have that same type of flow. And you can choose whether or not to fix. Right? You don't have to necessarily do any kind of enforcement, but at least you'll know something has happened, and I think that's kind of what we're going to see. So Ankush, if you want to come on up.
Yep. Perfect. Well, if we are talking about a lot of containers, we can't ignore the registry. And then there are two flavors of security. First is, am I allowed to do a Docker pull, right? Or if I'm allowed to deploy a Dockerized application, right? And the other is what's inside my container, right? Containers are not empty. It has a lot of binaries, a lot of different types of binaries. What if there is a security issue associated with the binary, which is part of my Docker image, right? But before I go deep into Xray, since most of you were not part of the first session, I would love to talk about how Artifactory fits in, right? What S2I is, because my demo is based on S2I. So let me step back a bit by a couple of slides. Okay, perfect. We had like one big deck. Okay, perfect. So where does Artifactory fits in OpenShift? So we have a lot of containerized microservices running on OpenShift. These containers, they are not empty, right? They need binaries. Binaries are different types, right? So we have developers writing a lot of code, which is good, right? And they depend upon binaries. Similarly, we have build tools, CI tools like Jenkins, OpenShift S2I, which is a very powerful tool. So they need binaries as well, right? So and my ops team, they also need newly generated binaries, right? So they have binaries flowing across silos. And to fill this gap, we need Artifactory, right? So Artifactory acts as a source of truth for all types of binaries across all silos, right? This is like a simple S2I command. It's very, very powerful, OpenShift S2I. What it does is, given my source code, how I can Dockerize it without actually knowing anything about Docker, right? So this is what S2I does. We can leverage Artifactory as source of truth for all types of binaries. So this is my last slide about S2I, and then I'll jump back to Xray. So how S2I works is, so this is my builder image, which is responsible to Dockerize my application. So this is like any other Docker image. So there's a Docker manifest, couple of Docker layers, and there are two magical files part of this builder image. The first is the assemble, which is a build script. It's a simple script. It has starts with source copy, and then there's a build statement. So for Maven, it's going to be Maven install. For NPM, it's going to be NPM install. And for C++, it's going to be CMake, right? And my run is my application runtime script. So given my executable, how do I run my application? What this S2I does is like it initiates a git clone. It runs this build script, which is assemble, and it creates this executable. And how it Dockerizes it is that this executable is part of the new Docker layer that is being added, right? So now, since we added a new Docker layer, we have a new manifest, and we tag it differently. And whenever we run this, my final application image, my run script is being executed, and boom, my application is running, right? So this is what OpenShift S2I is. And the same thing can be leveraged in like Blue Ocean or Jenkins. The S2I scripts, which I just talked about, the YAML version of those scripts can be leveraged in Blue Ocean. So this is what the pipeline looks like. And this is a pipeline for Node.js. So far, so good. Can I jump to Xray? OK. And again, it's interactive. Feel free to stop me if there are any questions. OK, perfect. So we talked about the Artifactory's role, right? And now we have a lot of containerized microservices running in OpenShift, right? What helps is, like from security point of view, is to monitor the entry points very, very closely. Like how are these microservices being born, right? So the entry points are the first line of defense. If we take a close look at them, monitor them, then half of, like from security perspective, more than 50% of our problem is solved, and I'm still being moderate. Here's the first entry point, right? So I already have an image, and I just want to deploy it in OpenShift. So that's the first entry point. So let's go from right to left. So I have my containerized microservices running in OpenShift. There's a deployment configuration file which specifies how my Docker image should be deployed in OpenShift, right? And it needs a Docker image. So ideally, if my Docker image is vulnerable, this deployment should fail. And this is one of the enforcement policies that we will be demoing. My second entry point of these microservices is that, hey, I don't have an image, but I might build one using S2I. So we use OpenShift S2I to build these images in OpenShift. And when I leverage my deployment config, that's where my application starts running in a containerized way. So in this example, I have my containerized microservices running. I have Artifactory in between acting as a source of truth. So I run S2I, which I just demoed like a glimpse of it. So I use S2I. It needs a source code. It will create my Docker image, right? Now, there are a couple of ways where policies can be enforced over here. So say if I am building a Docker image, my dependencies, like say maybe it's a simple Node.js application. I'm relying on NPM dependencies. If those dependencies are vulnerable, my build should fail, right? So I'm stopping the vulnerabilities from spreading right at the entry point. So they are the two entry points. So we'll demo both of the scenarios. We'll demonstrate how policies can be enforced. So where does Xray fits in, right? So we have containerized microservices running. We have Artifactory as a source of truth. We have developers. We have Jenkins and OpenShift S2I. So Artifactory has all the binaries of multiple types, and where Xray fits in is it does a deep scan of all binaries, of all the supported types of binaries in Artifactory. So it supports like from NPM, Bower, Docker, Debian packages, Yum packages. If you have RPMs, it figures it out. Maven, I believe that's about it. And we are still adding, keep like working hard to add more and more technologies, right? And we do our best to avoid false positives. So like for example, if we just take a look at the Docker file, right? We do like initiate like a from base image, and the next action we do is Yum update, right? So we do notice what all files are being removed, and we don't show such false positives as part of security report. The worst thing that can happen in a security report are false positives. So we do our best to avoid false positives. Okay, so there are multiple ways where we can enforce policies, right? And we'll be demoing this. So first is my deployment should fail if my Docker image is vulnerable, right? And my build should fail if my dependencies are vulnerable. And with S2I, one of my input is a Docker image. So even my builder, my S2I should fail even if my builder image is vulnerable, right? So there are two entry points, but 3 variations. So let's take one step back a bit. Let's see how Xray works. So Xray sees all these as binaries, right? As Shlomi and Fred mentioned at the keynote, like we are binaries people, right? So Xray is similar, okay, everything is binaries, that's what it scans. But it has a different perspective of these binaries. So there are different types of binary, different versions of binaries, and there are different types of binaries. Some binaries are more complex, like there's a Docker image, it has multiple layers. Each layer is like a tar.gz file. One layer can have multiple RPM packages. The other layer can have a WAR file, jar file, JavaScript file, right? So multiple types of binaries. And then there can be multiple issues, like multiple security issue. Maybe there's a DDoS attack, right? So it has a different perspective of all these binaries. And there are different types of security issues, right? Like there can be security issue, or maybe an export compliance issue. Or maybe I'm using a competitor's jar, that's another threat, right? So there are different types of issues. But the main question to ask is, given an issue in my binary, what is my impact, right? So say if I found that, hey, okay, my JavaScript is vulnerable to a cross-site scripting attack, right? Then what all files are affected? Like maybe my WAR file is affected, maybe my Docker image layer is affected, maybe a couple of Docker images are affected, right? So the main question to ask is, given an issue in a component, what is my impact? And this is exactly what Xray does. It creates like a very complex component graph of all the binaries, not only the third-party binary, but even the company's own IP, right? It creates this component graph to do the impact analysis. And as the binaries are growing in Artifactory, as developers are pushing, my CI engine is running and generating a lot of binaries, this graph is evolving, right? So in this graph, there are good binaries, there are bad binaries, and there are impacted binaries. This is a easier, a bit intuitive view of the component graph. So over here, like the child node has an issue, and all the ancestors of the child node is my impact, right? So this is a look and feel of the component graph in Xray. So over here, so there is a script.tar file. This is being used by our Docker layer, and this Docker layer is being used by a couple of Docker images, right? So that's my impact. And given a component graph, I can do a lot of things. Like for example, I can know the replacement cost. Like if I have to upgrade my tar file, right? I know what all Docker images are impacted, right? If I want to patch this, or if I want to deprecate this tar file, what is my impact, right? And the beauty of it is we can leverage this component graph with data, right? And that's where security comes into picture. So we look, okay, what all data is already available? So these are secondary sources of data. So Xray, out of the box, it connects to its own Xray database, which is sitting on the cloud. It pulls data from SNCC. It pulls data from component data from at least 6 data providers. And it pulls security data, again, from at least 6 data providers. And apart from this, it supports out-of-the-box integration like Aqua, Black Duck, and White Source to pull more data, right? So you have component graph, and you have more and more data to do the impact analysis. But we talked about the secondary data, right? What about the primary data? Or what about my own binaries, right? So typically, enterprises, they have invested a lot in security teams, performance teams, QA teams, legal teams, right? What all data that they generate, it's either in Excel spreadsheet, or it's in Jira, right? Or a BugDB, right? Or it's wasted. And if it's wasted time and wasted money, right? So we should handle all this data the DevOps way, right? Xray has good rich set of REST APIs. Use those APIs to inject primary data, right? For example, if I'm building my application like a Node.js application, I know there's an issue, right? I should be able to leverage that, hey, okay, given an issue in my own IP, what is my impact, right? So yeah, this is like a sample of REST endpoint. I mean, it's public API. This API can be leveraged to inject primary data, like a primary issue. So Xray, Artifactory, and OpenShift, it's very easy to enforce policies based on secondary data, which is already out there, and also the data which is part of your own companies, which is hidden somewhere or being ignored, right? And this kind of data should be handled the DevOps way. So let's go through a demo. I'll go through the look and feel of like what Xray is, the component graph, and then I'll be enforcing policies. So like, for example, if a Docker image is vulnerable, the deployment will fail. If a Docker image, again, is vulnerable and I'm using S2I, my S2I build will fail. And as part of my third iteration of this demo, I'll actually fix one issue and then run a build, and the build should succeed. Now let's get into action. Any questions before I jump onto the demo? Or I'll ask questions after the demo. I think that's when you will trust me. Yep, by default, I always go to a terminal. Okay. So there's an application over here. Let's go through the deployment config file and see what it does. So this is simple deployment file. What I'm trying to do, actually is the wrong one. The vulnerable one is this one. Perfect. So this is a file I created a couple of days back. It's one of the sample applications which I demoed this morning in my first talk. So I'm trying to deploy an image which already exists. So this is my first entry point, right? And if I take a look at the Xray, so I'll focus on the alert and then go through the user experience. So this Docker image, it has 4 issues, right? So 2 of the issues are in the RPM packages, and 2 of the issues are in NPM packages. So again, irrespective of the technology types, we nicely aggregate all the data, right, under a Docker image. So there's one NSS package. It has a critical vulnerability, and this is the one that I'll be fixing. It uses mini-match, and it's prone to a DDoS attack. And similarly, there are other issues. There's another NPM package. Again, this data is being pulled from Xray. And then there's another package which is part of the base image which I'm using. So let's try to deploy this vulnerable image in OpenShift. So if you deploy, The Docker, yep, here you go. The Docker image pullback fails, right? Because Artifactory is not allowing the download of this Docker image. So that's the beauty of having Artifactory as a source of truth, right? If you have a single source of truth for all types of binaries, it's very, very easy to enforce policies. So this is one example. Before I start my second, I think I'll explain two more things. It will help because a couple of you they were not part of the first session. So this is the look and feel of Xray. I'll just quickly navigate through it, and then I'll navigate through the look and feel of OpenShift origin. So this is what Xray looks like. There are alerts at the top, the vulnerabilities on the right, recent ones. It's connected to one Artifactory instance. And these are the recent components and the technology supported. But the beauty of Xray is the component graph, right? Like say, let me navigate, let's say this one, right? So over here, I see all my Docker layers, right? And like if I click on the top, it aggregates all the issues over here. And I can drill down layer by layer. So these are the RPM packages that it detected, right? And so this is Xray, and this is my OpenShift origin. So it nicely lists out all my applications which are running. If I see dark blue circles, that means everything is good, right? So there are multiple applications, and as Chris mentioned, there's persistence. Not every application is a true like stateless. So it has good persistent volume support. So an application needs to create persistent claims, which is linked to persistent volume. Now let's move on to the second part of the demo. So I am deploying an application which was built in the morning, but I made one change. I modified the base image. And the base image which I'm using, it has the vulnerability in the NSS package, which is part of, yep, okay. So let's take a look. So over here, let me show you YAML version because it's easy to edit. So this deployment, it just tells, okay, what kind of strategy is it? Like, is it rolling update? What file should I deploy? Environment variables if it needs one. So over here, what I'm doing is, oops, sorry, wrong one. My second part was S2I. Yep, here you go. This is my build config file. And the build config file can be leveraged in Jenkins, Blue Ocean as well. We don't have to reinvent the wheel. So over here, it's a sample build file, S2I file to build a Node.js application. I'm specifying a GitHub URL. Yep, and I'm relying on this file. So this is my builder image, right? So I'm relying on a Node.js 6, a CentOS 7 OS, which has Node.js 6 installed with it, right? So let me save this, and let me try to run the build and see what happens. So the pull of the image should fail. And how it works behind the scenes is Xray detects vulnerabilities, and it notifies Artifactory. And Artifactory, what further it does is that it plays with the metadata. So like over here, if I go to manifest, yeah, over here, it's saying that, hey, okay, Xray has detected issues on this artifact, so it's blocking it from downloading. And if I go back, whoops, I think that's the beauty of a live demo.
You didn't change it.
I didn't change it?
Still pulled from the latest. Latest wasn't one block, was it?
Yes. Let me check. Give me 2 minutes. That's the charm of live demo. It worked 20 times, but on the 21st time when you're showing live, it won't work. Let's see what happened.
So something else to consider, right, is while it didn't stop there, there's going to be times you don't want to stop it. Like, so maybe your CEO's stock bonus calculation app is the service that has the vulnerability. You wouldn't want to necessarily keep that from, getting updated and fixed, right? That's kind of the beauty. You can pick and select and choose enforcement or just choose awareness, going back into capture and diagnose. You don't necessarily have to apply a fix and block it. That could be bad, right? And so that's kind of, the other piece here. So did you figure out which one it was?
Yeah, I had a question.
Sure, let's do some questions.
Yeah, let's do some questions meanwhile.
You guys talked about kind of the life cycle, so after, it's like I have a vulnerability, can I go into Jira or something like that, or how, is there a workflow to get rid of those images?
So I guess you would do that within get rid of the images?
Yeah, I mean,
Yeah,
if I'm
yeah.
storing them and they're vulnerable, ultimately, I don't want them there at all anymore. Is there
Yeah, I'm going to presume Artifactory, you get that.
Yes, I will,
there.
and I found my issue. Yeah, here you go.
So yes, you can remove images. Again, that's one of the reasons so OpenShift has its own registry as well, but one thing we found is a lot of customers use Artifactory for that very reason. Like they even don't necessarily want the ones coming directly from Red Hat. They want this intermediary that they can set up and manage and say, okay, these are the images that I trust. This is my canonical source. This is what I want my developers to use in the environment. And so if there's one that's bad, you absolutely could take it out, or you just leave it in and say nobody can use it, which is what we were trying to demonstrate here with Xray.
Perfect. So coming back to the demo, over here I'm building my application. It detected a bad NPM file, so it failed the building of the Docker image, right? So my NPM build itself failed. I don't have image being created in S2I, right? And what went wrong in the last one is this. Node.js 4.
Yeah.
Let's see if the magic of the live demo. Yes. Right? So, and how I fixed is I went to a Docker file and I updated the NSS package, rebuilt it, it worked like a charm. So there are different kind of enforcement policies that can be enabled in the pipeline itself. But at the same time, Artifactory, you can create like a lot of repositories. So the dev will work on a different repository, my prod will work on a different repository, because you don't want to fail a build for a developer, right? Because you don't want to pause the development. So a developer should be able to build anything, right? It's only in the pipeline when it's very, very important to scan, make sure everything is good, right? And yep, I think that's all what I had to demo. Just wanted to demo various kinds of enforcement policies.
Yeah, and so one kind of note on that, we do want to ensure that the developer is always enabled, but that's also why we're investing in tools and other partners on the kind of the IDE side, especially to help identify that for the developer. So within your IDE, it would say, hey, this is probably a bad package. You may want to consider updating it before you actually put it out there, and that's part of it as well. So we got to handle both personas, right? The folks on the back end, running Xray from the administration and operations standpoint, and then the actual end developer. How can we make it as non-intrusive, but give them the information is kind of the goal here. So any more questions? We've got a few minutes, I think.
Yep.
Yes. Okay.
This is across the board, right? This was Origin. The demo was with Origin, but OpenShift Online. any of that stuff works the same way.
Yeah, in this case, I don't think you're not dependent on anything past 1.5, right, of Kubernetes?
Yeah, but so wherever Artifactory is supported,
Yeah.
this piece fits in right away. Xray is working with OpenShift, not inside of OpenShift yet, but it's able to scan all the applications running on OpenShift. So,
Like all versions of OpenShift, right?
Yeah, so-
OpenShift Online, I think OpenShift Origin.
Right.
So
Right.
we have- yeah.
Just like, I mean, we're open source, so we'd like to do all the development we can upstream out in the community and let folks see what's going on and everything. But what we did publish this week from the Artifactory standpoint is a supported reference architecture. So we're going down the path of this being on all the commercial bits as well.
yep. So yeah, right now in the morning we demoed Artifactory Enterprise on OpenShift Origin. But again, there's no, like we support whatever we test with.
For every security vulnerability, there's a risk associated with it, whether it is low risk, medium, or high.
Yes.
So if it is low, how would you handle it later? So does Xray allow you to configure?
Yes. So in my Docker image, at least, so there are a lot of vulnerabilities. I'm only failing builds for critical vulnerabilities, right? So there's a way I can actually show you on the UI. There's a way you can set up policies. Both, so the block download policies are part of Artifactory, which is what Xray leverages. So whenever we create a repository, say Docker Hub. So I have an insecure and a secure repository. Insecure is meant for developers, where I don't want to piss them off, right? And this is my, being a developer, I know the pain. Used to be, so yeah. So over here, this repository is being scanned, indexed by Xray, and I'm blocking downloads for only critical issues.
Yeah. Cool.
All right. Any more questions?
Is it possible to redefine criticality levels? Let's say it's a component we just does not use, a functionality which is not used by the application.
Yes. So, I mean, so there are multiple ways around it. So currently the policies, let me think about it. So if it's part of a different repositories, it's easy. If it's part of the same repository where you have like all the artifacts, then it's a bit tricky.
Yeah.
Again, you can play with it. If it's a secondary data, it's tricky. If it's your own primary data, and if that risk is not relevant to you, you can lower the priority.
Yeah.
Also, on the Xray side, you can create watches. So you can have a watch, you can add a regex, regular expressions that, hey, if this is my pattern, I want to lower the bar. So that can be done in Xray. Okay, cool. Leverage your primary data. That's the note I want to end with. Thank you.
Thanks, guys.